Okay, this is the area and perimeter of regular polygons, part 2. So part 1 was I went through a hexagon and an octagon example. Now I'm going to go ahead and do a pentagon and then just a random 15-gon. I don't even know what the name for a 15-gon is, but a regular 15-gon. Okay, so a pentagon. We already discussed that each interior angle for any regular shape is n minus 2 times 180 divided by n. So we get 108, and so we're going to do the same thing we did on the hexagon. And the octagon. We're going to take this. You know what? Last time we did a radius and we did a side length. Let's say we knew the apothem. So this is a pentagon with an apothem of, let's say, 14, and let's say it's in meters. Okay. Again, I know if this angle is 108, that means this angle is going to be 54 degrees. That's a right angle, and I'm going to work with this little triangle. I'm going to call this X, and I'm going to call this R. I'm going to use trigonometry, so I'm going to say that tangent of 54 is opposite over adjacent. And then I'm going to multiply both sides by X, and then I'm going to divide by tangent of 54, and I'm going to find a value for X. Okay, so 14 divided by tangent of 54 is going to give me 10.2 if I round to the nearest tenth. Okay, and in this one, let's use the Pythagorean theorem instead of trig. I could use trig to find r, but let's say that we know now that 10.2 squared plus 14 squared has to equal r squared. And let's do it that way this time. So 10.2 squared plus 14 squared is 300.04, and then we just got to take the square root of that. Okay, so we get an R value that's really close to like 17.3, and these would be in meters. Okay, so I had the apothem of a pentagon, I found the radius, and I found X. If I wanted to find the side length, of course, so the side length, of course, is just double this, because X is this little base of this triangle, but the actual side length would be 20.4. Okay, so I know the side, I know the radius, I know the apothem, and now let's find the area and perimeter. Okay, let's find the area of the little triangle. Again, that's how I've been doing all of these. So I'm finding the area of that little triangle first. Triangles are 1/2 base, which is X, 10.2 times the height, which was given as 14. Okay, so 1/2 times 10.2 times 14 is 71.4 square meters. Okay, that's the area of the little triangle. And then the question is, well, what's the area of the hexagon? Well, there are 10 little triangles. Remember, if there are 5 sides, there are 5 big triangles, and then there are two little triangles for each one of the big triangles. So there are 10 of those. So all I have to do is multiply that by 10, and that's really easy. Multiplying by 10 is just moving the decimal. And I get an area of 714 square meters for the pentagon. And then the perimeter, of course, is just 5 times the side length, which we found was 20.4. Okay, so 5 times 20.4, what is that? Is 102. 5 times 20.4, just to confirm, is then 102 meters. So it's 102 meters around this regular pentagon. Again, it is a regular pentagon. If it was just a random pentagon, we couldn't do it. But it is a regular pentagon, so its interior angles are 108, so that angle is 54, and then we can do trig and Pythagorean theorem, and just be careful when we're finding the area and perimeter. The area is, for what I always do, is I always find the area of this little triangle, and then multiply by 10 in this case. All right, how about we do a 15-gon? Don't even worry about drawing the 15-gon. You just know it's got 15 sides, okay? I'm going to then draw the little triangle. How many little triangles are there? Well, there are 30 little triangles, okay? So what's this angle? The interior angle for a 15-gon is, again, just doing 15 minus 2 times 180 over 15 is we get 156. So we take 156 and we split into half, and we know then that that angle is 78 degrees. Let's say we knew, let's say we knew the radius. So we knew the radius of this guy was 8. Okay, so we do know that that distance is 8. And then we want to find the apothem, and we want to find x. And when we know those things, then we can find the area and perimeter of this 15 gon. I mean, we had to know something about it. The apothem, the side length, or the radius, or the perimeter, or something. So let's give you the radius here. All right, let's do some trig. So we say that cosine of 78 is equal to x over 8. So then 8 cosine of 78 does equal x. We type that in. 8 cosine of 78 is equal to 1 point, we'll round it to 1.6. We've been rounding the nearest tenth, which is fine. Okay, that's x. And then let's do sine. Sine of 78 equals h over 8. So then 8 sine of 78 equals h. H equals 8 sine of 78, 7.8. And let's go ahead and say these are all in feet. So that's going to be in feet, and that's going to be in feet. Okay, so then the side length is just double x, right? Side length is double, right? If you find x, double it to find the actual side length of the polygon. So the side length is 3.2 feet. And then we can find the perimeter of this 15 gon. A 15 gon is 15 sides, so just 15 times 3.2. 15 times 3.2 is 48 feet. Okay. The area of this little triangle, right? The area of the little guy is 1/2 the base, which is x, 1.6, times the height, which is 7.8. So 1/2 times 1.6 times 7.8 is going to be 6.24, and that's square feet. And again, the area of the big guy, the 15 gon, remember, the little triangle is half. Right? It's half of, I guess, one of the bigger triangles. There are 30 little triangles in this. So all we have to do is take 30 and multiply by the area of the little triangle to find the area of the 15 gon. Again, it's a regular 15 gon. Maybe I should have wrote that as well. You get 187.2 square feet. Again, a regular. If it wasn't regular, then we couldn't break it up and find out each interior and then cut it in half. Okay, so that's two kind of more examples leading you through. This one was a regular pentagon, and this was just a regular 15 gon. You're not going to have the picture for something like this, but all you have to do is draw the little triangle just like we did here. Take the interior angle and split it into half, because that's what the radius does. The radius does in fact bisect that angle. And then we can use trig. If I know the apothem or the side length or the radius, I can always find the other ones using trig and or the Pythagorean theorem. Once I know these quantities, I then can find the perimeter of my polygon and the area of my polygon. I always find the area of the little triangle and then just multiply by how many little triangles are in the regular polygon. There's always double the number of little triangles as there are sides. So if we look back here, again, the big one, if we actually drew all of those just to kind of reemphasize, they're all the little triangles. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 little triangles. And again, in this case, there's going to be 30 little triangles, which is why I multiplied by 30. Okay, so you got pentagon, a 15 gon. Again, hopefully you can do it for any one of them, but if you watch both of those videos, you should have a very good start on how to find the area and the perimeter of regular polygons.